Let's do this. Plus, we finally got the dog in here. Hey, buddy. Okay. What do we want to do? We want to talk about Finch today. Let's try that out. Make sure I've got things off of my screen before we really get it going. Okay, that looks good. Oh, I need my ECR tag. Hey, hey, hey. Welcome to Check. Good to see you again. We'll flip back over here, just getting started. Finally convinced the dog to join me here. He's waiting for more treats. Okay, so last time where we left off, we've been building this, this set of test systems for Python on Lambda. I have been using a Docker and I've been using zip-based Lambda functions to compare the performance. It's gotten a lot better. One interesting thing that I wanted to try out today is Finch. So Finch, or I think I've got exclamation mark Finch in the chat too. It's just, does that work? All right, yeah. So there's this container. I can close my meme too now that I posted it. Finch is a CLI tool for building container images and developing them locally or for yourself. So there is a pretty sweet little set of tools published here that includes like nerdctl, containerd, and buildkit. So you can do kind of a lot of things that Docker Desktop could do for you. And it's free and open source. And I think it just like probably solves a lot of the issues I've been having so far with Docker. So I think if you recall from the stream before, I've had a couple of times where like I had to log into ECR, which is Amazon's Elastic Container Repository, just to authenticate so I could pull an open source layer. Like it's totally public, but it was giving me a hard time just logging in or out all the time. And I was just sick of it. And I think so far it's definitely solved that problem for me. So pretty excited about that. Do I not have the Python? Here we go. Yeah. So now I want to build some images and push and see. It's not AJ Bun. It is this. Boom, boom, boom. How is it going? Is it Kochi? QQ? Hopefully things are going well. Boom. It's Docker push would be the command. And what is the... Yeah, doing great, doing great. Thanks for asking. So in theory, you can replace all of your Docker commands with Finch and it just works. Oh, I might have to authenticate as myself here. 401, yep. What is my, okay, ZSH aliases. I forget the Docker login. It's just, so let's just try if we can do like a Finch login maybe. Oh, and I also got Copilot working finally, so we can see if that helps us out at all. Python container. Oh, nice. I've not done a lot of WASM. I think ever since Figma hit it big, kind of built entirely on WebAssembly, it's something I've been meaning to look into. I did see like a couple of performance benchmarks that looked pretty interesting. Although, like I think I've talked about over and over on the stream, like benchmarks aren't always like benchmarks shouldn't be your decision making. It should just be a input into paths you choose, and not necessarily like the technology itself. But okay, what do we want to do here? AWS profile equal personal, and then it's AWS Finch login. Will that work? amazing. It's going to work. This is great. So Finch, I think I like Finch already because it seems to have just copied the same Docker API. So all of my scripts, all of my aliases, all of my, dot files, everything is just going to work right out of the box with it. I just have to call, like I could probably just alias Finch to Docker and be done, which is just great. Let's see this. Why did it give me a 401 now? Oh, I know why. Export AWS profile. I like it more because of the sandboxing. Are you running like untrusted code? Like, are you running like user code? Like users are going to upload some snippet of code and you're going to execute it using a WASM module? Yeah, makes sense. Oh, oopsies. I exported. Why is this not working? Okay, maybe I do need to log in. Finch, log in. Log in? Oh, there's a cred helper. Ooh. That's just configuration. So the VM's running. It can build. So like we can do Finch build. That seems to be great. Yeah, if you had to run untrusted user code, I totally understand why that would be something you'd look into. I think from a performance standpoint, that's obviously why Figma chose it, but I think that's pretty awesome. Okay, Finch push. Oh, is this not the ECR? I wonder if it's not the right. View push commands. I think that's right. Oh, maybe we'll tag it. Oh, I wonder if okay, no, hold on. It would help if they, oh, Figma, yeah. I understand why they don't. I mean, it's their, it's their business. Performance is their business. I understand that. I mean, performance is Datadog's business too, right? So I can kind of see an aspect of that. Although I think we do have, like we've written a lot of papers and published a lot of open source toolkits for stuff. Yeah, for sandboxing, that makes sense. I wonder if they do any actual sandboxing code in Figma. I have no idea. This should work. Let's just run these commands again from the beginning and make sure I didn't screw them up. It's actually in WASM. Oh, interesting. I didn't know that. Oh yeah, plugins, of course. That would make sense. Okay, I didn't even think about plugins. Why is dot? There's like a Finch, whatever. Boom, boom. Okay, maybe I tagged it wrong or pointed to a different, maybe I pointed to a other AWS account. That could be what's going on here. So one of the challenges that I have is the serverless framework shells out to Docker already. So it's expecting a, like it's calling the Docker command. So I have to build all of this myself and push it and just tell the serverless framework that I have an image already written, which is fine. And we're doing Python right now. One experiment I wanted to do actually on stream, which I might not get time today, is to talk about one of the most common mistakes I see for people building event-driven asynchronous applications on Lambda, and that is using something like SQS and basically not reading the docs. If you throw an error in a Lambda function that's invoked asynchronously, it will retry, which is great, and we want that, right? But with SQS, it will actually start like blocking messages and it will re-execute the same message. Or if you have a batch, it will throw an error for the whole batch. And there's a system for this. There's like a tool called batch item failures. And there's actually a very awesome tool where you can send like a partial batch response. This was like a year ago, 2 years ago. But it basically allows you to say, hey, part of this batch failed, part succeeded, requeue the ones that failed. And when you do that, that is awesome because first off, those messages that you succeeded aren't reprocessed. And secondly, you don't actually have the secondary problem of scaling, which is SQS will throttle your Lambda functions when they start failing. Oh no, I don't know if we have. I have to find it. Basically, SQS will limit the concurrency of your Lambda functions if you start throwing errors. Oopsies. Oh, I don't want to. Did I run Docker build or did I run Finch build? No. All right, we tagged it. Uh-oh. Okay, Docker build. Let's rerun this. I didn't. That will take some more time to set up. I want to do a whole video on that. And actually, so one thing that is cool is I have a draft blog post today that I've promised everyone I would finally ship, which is about why you shouldn't use Lambda layers. And I want to try reading through it on stream with the hopes of turning that into a video. So I'll edit it up, after the fact. And we'll get into this in a little bit. But I finally put down all of my thoughts as to why I don't think people should be using Lambda layers for a number of things and some of the failures that can occur as a result. I think I've talked about this over and over on stream. I've ranted about this on stream, but I'll finally actually give the whole thing end to end, which should be good. But first, I really got to get Finch working. So Finch build, Finch tag. Okay, that worked. Finch push. Oh, I need. Where did my console go? Okay, I think I had the wrong. There we go. Okay, I must have had the wrong thing. Hey, Sir Cantor, Lambda Power Tools actually has nice callbacks implemented for SQS bash failures. Yes, it does. It totally does. And welcome to the chat. Thanks for joining. Power Tools is awesome. I'm a huge fan. Aitor Lessa and I are friends. I've visited him in Las Vegas at reInvent together, and he came and visited us in Boston just a little bit ago. He's the principal engineer for the project. Dream Morrissey, hey, welcome to the chat too. Thanks for dropping the link to Power Tools. Great project. I highly suggest using it if you're new to Lambda. It's totally worthwhile. Awesome, this is great. Finch is good. Join us at reInvent. Yeah, I'll be there. ! reInvent. You can get information about the talk I'll be giving. I'll reInvent. If you're going to reInvent in Las Vegas, let me know. We'll be there. Oh yeah. Okay. I don't want to. Dream Morrissey, I think I know who you are. I don't want to out you on my stream though, since you have an alias in chat. But I think I'm signed up for that workshop. Unless you're not actually co-presenting with Aitor. I'm not sure. I know that he's doing a presentation with somebody else, and I'm not sure if that's you because of the name. Okay, this worked. We just pushed. This is awesome. And it should be a second image, right? There should be a new image in here. Yeah, latest. Boom. Okay, so now we need serverless framework latest. I want to make sure end to end that this is working with Finch. Here, let's see. Here, we'll show the dog view quick. There we go. There's Taco. Hey, little buddy. Here, we'll give him a treat. I finally got a rug in here. Taco would not hang out in my office until I got a rug, and now he's just chilling. I gotta make it lay nicer under the chair though. Thank you, Sir Cantor. Yeah, he's my buddy. My little buddy, gonna be 7 years old on Christmas. Okay, let's go back. I didn't want to forget to change the scene. Serverless framework. Oh, sorry, latest. Container image support. I should know this. I was here when we did this. Yeah, it's name, but you can usually give it a path, right? Image. Okay, perfect. All right. Let's just grab this. So we don't need any of that anymore because we're going to build it ourselves with Finch. Oh, we need to pass platform as well, don't we? I think I can pass it here, right? that work? Let's find out. Finch build. Okay. Oh, it doesn't like that. From requires either 1 or 3. Oh, it should have a space, right? Docker build platform. Docker file. I just forget this. I know it's -- platform, but there's a way to do it in the file itself. From -- platform. Okay. So in the beginning, let's see if Finch does this. This will be a real bummer if Finch doesn't do this. I'll have to take back everything I said about it. Oh, it seems like it's doing that happily. Does it say the architecture? If anyone sees x86 or AMD 64 in here, let me know. Cool. Hope everyone's doing all right. I know there's a bunch of new chatters in chat today. Thanks for stopping by, saying hello. Yeah, Finch supports the platform flag. All right, sweet. It's building right now. It looks to be just fine. Thanks for the docs. So far, it's been great because it hasn't crashed on me like I've had issues with Docker Desktop, and it hasn't had the login logout error, which I get every single time on stream, and it's just been driving me nuts. Oh, and I want to try Sochi as well. I've actually only really read about it, and I tried a pre-prepared Sochi image and like did a before and after, and it's pretty impressive. Sochi stands for Seekable OCI, or Seekable Open Container Image, which just helps you lazy load. Hey, BKR Dev, welcome. Sorry, light mode hitting hard. I know. I do mostly dark mode in the AWS console, and I do mostly dark mode. I do mostly. What do they call it? Like follow the sun mode. Yeah, it hits though. We'll leave the AWS console in dark mode for you. Hey, we built it. Okay. Okay, Finch tag as latest. Finch push. So far, Finch feels nice and snappy, and it does everything I needed to do. I can respect it, just wasn't prepared for it. Yeah, I should probably have like a light mode warning in this channel. Okay, that worked. That's awesome. Let's edit the serverless file. Let's remove the part where it actually builds my image, because now we're using Finch for it. And I should have a latest tag. Okay, awesome. Now I just want to. This should just work. If everything here works, is great, and then we can go off and build a little larger one. And then I can give my Lambda Layer rant, which I'm very excited to do. Go back to the dog cam after the deploy, or during the deploy. Hey, buddy. Hi. He's got the littlest of tail flicks. He's just happy to sleep and hang out all day. It's pretty great. I know I'm in US East 1. That always makes me laugh. I think if I were to start a company tomorrow, the first thing I would do is deploy my production stack in US East 2. Oh, let's slap a function URL on this. Yeah, yeah, we do use ESE2. Exactly. Like, you get everything that you would want from ESE1 with none of the, or less of the instability and the, beta testing issues. When is dedicated dog cam coming out? That's a good question. We should, maybe I'll talk to Dax and see how he did it with Zuko cam. We could probably do something. Come on. There he is. He's looking. The dog cam, or the entire stream, will be dedicated dog stream in about 2 hours when he decides it's time for him to go for WALK. All right. On AWS, We know that this is going to be a really horrible cold start at first. The very first time you execute brand new code, there's 0 caching, so all this has to be loaded from UCR, and that's totally fine. But after that, cold starts are pretty typical. Okay, executed successfully. That looks great. So this is all working. Finch did it. That's awesome. That was super fast. Okay, let's go down and make a 150 megabyte Python. I want to see, oh, it does exist. Did I create one already? Oh, I did. What do we do here? Right, so we created the virtual environment. We've got the, okay. We're in the virtual environment. Asking the real questions. All right, 120. I mean, we're bringing our own Bodo 3 though, which is still going to be in the runtime anyway. That's okay. Okay. The thing I love about Taco at this age is that he's really chilled out a lot. When he was a little puppy, it was just all go all the time for the first year, and then he finally mellowed out a lot. He still loves to go on long hikes, and he doesn't really run with me anymore. He ran for a little bit when he was little, but he doesn't like to do that so much. But now he's just, he needs a solid hour of playtime every day, and then he really wants to just curl up and be a part of life with us, which is pretty awesome. Dogs are great. 10 out of 10. Would recommend. We've lived with him in apartments. I had a house and a big yard with him, and now we're back in an apartment. It's fine. Hey, George. Welcome to chat. He is 6 going on 7. He'll be 7 on Christmas. All right. We should deactivate and go to the next directory. Let's see if we can rebuild this. Yeah, it's sad. Dogs, 7, 8, 9, 10 years is getting senior for them. Can serverless framework... Wait, hold on. Opt, homebrew, bin, serverless. Oh, is it a symlink? Oh, it's actually a binary. Oh, no, it's not. Okay. Okay, let's see if we can modify it. Let's do some surgery on serverless framework and see if we can just plumb in Finch. Lib, node modules, serverless. Sweet. Okay. Here. Now this is what I really wanted to do, which is keep everything the same and just make serverless framework speak Finch instead of Docker. Where does it shell out to Docker? Everywhere. Great. Oh no, I'm still in that. Damn it. There we go. Spawn Docker. Do you think this will work? Oh, that's just to get version. Serverless.run. Where is the shell out to Docker? There's no way this is as simple as I think. CLI command schema, Docker arg, Docker. No, that's for invoke local. I don't care about that. So what I'm doing now is a little surgery on the serverless framework. I'm reaching inside of my local installed version of the serverless framework, and I'm going to replace the build step with Finch because I'm just so sick of Docker. I could alias it, but I don't know if I can do that necessarily because there's other things I do rely on Docker for, and I'm not sure if it's ready yet. but we'll see. Scripts Docker, Docker version, match group, changelog, changelog, changelog. Millions of lines of AWS SDK. It's got to be down here, right? It's got to be in the provider. Yeah, Docker push to, where's this defined? Push Docker args, push remote tag, buffer, await spawn Docker. Here we go. Finch. Okay, so there's a few places we have to replace it, right? Easy. I could just keep it in another. All right, do you guys think this will just work? This will be crazy if it just works. All right, let's find out. I've killed Docker. Docker is not running on my machine, FYI. So here, like, just grep. So it's definitely working. Just surgically replacing Finch into the serverless framework code. Replacing Docker with Finch is totally working just fine. It's cross-compiling, it's packaging, it's tagging, it's building. That's awesome. 10 out of 10 would recommend. Had a really nice Finch experience so far in the stream. We are 27 minutes in and I've deployed 2 Lambda functions using Finch already, which is pretty great. One kind of manually and one just by modifying my build tools. So now what we maybe want to do is open a PR to the serverless framework and let me specify like a Docker provider, like a Docker CLI provider. We could do that. Although, okay, so one thing I also needed to do, and I wasn't sure if I was going to do this with the SQS thing yet, and maybe we can decide. Hey, Sir Cantor, don't feel bad. I'm also shocked. I didn't think that would work at all. And it seems like it's working just fine. Tagging, uploading, building. I think it would have panicked by now if it was failing. We'll see though. I mean, it could still, like, let's not rush it. It could still panic. One thing I also thought about working on this stream that maybe I could float by you folks is I have this open source library called Lambda Stream. If you haven't done this before for Node.js, the AWS Lambda supports response streaming, but they embedded the method in the SDK for streaming a response into the runtime itself, like into their little bit of JavaScript code that interacts with the Lambda runtime. So it's just like a global that just is injected into your code. So, which is fine for running in Lambda, but it doesn't work locally. It has no type support. There's no way to test it. There's no way to, it just has to run. You import a magic class basically, and you import a magic library from a magic class, and that method just works in Lambda. So I've got this library that replicates it locally, so you can actually test it and get types for it. And one thing it doesn't do is it doesn't let you set headers, which you can just do manually. And here's how you do it manually. But a couple of users, like I opened the ticket and said, would people care about this? And 2 people just said yes. One person really recently. So I think that means they're Googling for this. So pro tip, if you have a open source library and you're not sure about a direction you want to go, but you're aware of the issue, open the issue yourself and talk about what it is. This will make it this will make it like Googleable. Hey George, why am I replacing Docker? I'm replacing Docker with something called Finch, which is a container CLI tool. It's written by AWS. There are a few reasons why. Docker Desktop, which I've used forever, is good, and I do have a license for it, but it's been crashing on me quite a bit, and it's been it has this latent issue with logging into multiple repositories at once, where I just have to kill it and restart it. It's got like some caching issue where it thinks the token is alive and is not. Reason 1 isn't Docker. Is it Baker Dev? Biker Dev? There could be any way you could take that. Yeah, Docker desktop. It's still a, I mean, it says Docker file, right? But it's a, you know, an open container image format is what's getting generated now. Check out that URL. Do you guys think in 20 years, like URLs are going to be seen as like cringy by the kids and they're all going to want these ridiculously long URLs like this one? Maybe that'll be in vogue. Okay, just BKR. Got it. Finch file sounds dank. I mean, we okay, fine. We can, well, the next one we'll do a Finch file. Oh yeah, just type in IPv6. Exactly. They'll be on IPv8 then. Kids will love it. Taco's passed out on his little dragon. It's really cute. Hey, buddy. Hey, buddy. All right. Sometimes it squeaks when he lays on the toy and then he wakes himself up. So this is something I've been meaning to look at and have been wanting to focus on this first. That's great. This worked awesome. I can't believe I just did surgery on the serverless framework live and it worked on stream first time. Okay. So once we get this done, I do way too many of these. Oh, is it Python 3 Docker? What is it? Oh, AWS Python Docker. There we go. My parents would dog would snort self to wake. Yeah, I mean, absolutely. Okay. So we want to CP 200 MB Python. Build a 3 pyramid open tracing scrapey. Okay, that seems fine. Come on. Come on, LSP, go. Okay. So I'm going to remove the handler, edit the app file. For whatever reason, I think we talked about this, serverless framework likes to give you a app file instead of a handler for Python or for wow, I can't think of the name for container images. So we need to remove this. And we need to copy requirements.txt. We need to run Python 3-m pip install-r require. That looks okay, and we need to change the format. Let's see, this should work now. Platform Linux, AMD 64, URL true. Did I forget anything? I don't know. Let's find out. And again, yeah, no tricks here. Docker is not running. That's just all my args for grep. And then Finch is alive and busy though. Look at that. Finch Lima. Finch, you are dangerously close to Ligma. Someone needs to tell them. Should we open an issue? If you're gonna let content creators talk about your project on stream, you should not name any file Lima. I finally caught up on the Primogens iLadies meme, and that cracked me up. I had not seen that at all. A little out of the loop. Finch Ma. It's good. I mean, it takes a special group of people to really give a shit about something to build something that's like a binary drop-in replacement for something else that honors all the same CLI commands and is as deeply done as this, and then have it just work like this out of the box. It's pretty awesome. And it's been solid. I haven't had to like kill it or log out or anything like I've had to do with Docker Desktop for the last couple months I've been streaming. Comes from this. Thanks for the link, Dream. Linux machines. Yeah. The one thing... Let Tim cook. Let him cook. Tej is smart. I am using Kickstart. I got him to crack up the other day on stream because I said I just Google Tej face kick and it gets me in the right place or something. He thought that was funny. I'm a fan of NeoVim. I think the work that they've done and the work that Tej has done to make it pluggable brought me back into NeoVim. Has anyone used this on Linux yet? I've not had issues with the CLI. I have not. I have not on Linux yet. I'm running on Mac OS today. We could fire up a T2 Micro and try it if we wanted, I guess. I sort of just let chat take the stream where we want it to go, which I think is great when I've got 5 people in chat. It works really well. I don't know how that would work if more people were here. BKR, I read Kickstart to understand, then built it like Prime so don't get lost. Yeah, do it a little bit at a time, you know? I don't use, I think there was a discussion in somebody's chat yesterday about, okay, Dream, yeah, it just for Mac OS. There was a discussion about chat like using like file trees in Vim, and you see mine already. Like I don't use a file tree. This is all you get, which is like the default listing. So I don't even use like nerd tree or NeoVim tree would be I think what I'd have to use. I just navigate like this, and that's okay. I do have. I think we can take a look at my init.lua open read only. So it's mostly the same. I changed the leader. I think everything else is the same though, right? Like Mason and Tree Sitter and Fugitive. Oh, I'm using ripgrep instead of whatever the default is. Mason Telescope, Harpoon. I have not used Harpoon. That's Primogen's project, right? I have not tried Harpoon yet. Did we do it? We did it. Yeah, I've not tried that yet. I should. I think I've been pretty productive with what I have so far, and to be honest, I used to really mess with this. Hey, okay. All right, that all seems good. Okay, so we have one more to set up, which should take another minute, and then we'll do the Lambda Layer rant. We did it. Yeah, look at that. Hey, you saw it here first. I ripped out... oh, we got a dog moving around. Hold on. What's he doing? Is he leaving or staying? Just finding this out. There we go. Good dog. I love you, buddy. He's the best. Question. Prior to the layer rant, do layers help with deployment time on CloudFormation CDK at all? It does. No, totally. It does, and I talk about this here. And this is on localhost. I haven't even published this yet because I have a couple of people I really respect and look up to who are looking at this and making sure that I'm not going to make a fool out of myself. That's not true. I sent it to people who work on this stuff at AWS, and I want them to feel like they're fairly represented, and I'm not saying anything out of line. That's not going to keep me from publishing, and it never does. Like, they have no editorial control over anything I do. Not that I do anything important, but I want to make sure I'm not missing something. But yes, Lambda layers can improve function deployment speeds, but so can your CI pipeline. You know, you can GitLab, GitHub, any kind of CI pipeline you're using, for the most part, as far as I've interacted with, have a lot of support for dependency caching. And typically the painful part is like compiling or building a heavy dependency, right? Or like running ES build. But if you have that, like if all you have to do is like ES build like 5 megabytes of JavaScript, that's not really going to be a big change. And if you don't change a bunch of your dependencies, that cache is going to be warm. So yeah, your CloudFormation deployment might be a little bit slower. I don't think I've had unless you have hundreds and hundreds of functions, I don't see a big win there. And if you do, you know, maybe there's an opportunity, but there's a ton of risk here that I also will highlight that I think outweighs it. Like, wait the 2 seconds, because Lambda layers can burn you in ways that like a normal package manager for any of, PyPy, NPM, PNPM, Ruby gems would prevent you from shooting yourself in the foot in the way layers allow you to shoot yourself in the foot. And for that, I just can't. And there's things they can do, and that's what I've asked them. It's like, give me two things. Give me semantic versioning for layers, and give me a manifest file. Let me specify this is a JavaScript, here's a package.json file, and this layer is for JavaScript. And that way, anybody who uses my layer in my company or outside of my company, right, because they can be public, anybody who does that can at least see what's in there, and their package manager or their build tool can tell them or warn them if there's an incompatibility. And you can't get that now. You literally just have to test it and hope, which is ridiculous. All right. But yes, we'll jump into the rant in a bit. I just want to set up. So there's two things we got to do, right? We have to set up the 250 megabyte demo project, and then we have to run it in our benchmarker. And if you're new to the stream, first off, if you're new to the stream, thank you so much for hanging out. Really appreciate it. Hit that follow button, helps me out. I've got 130 followers right now, so every bit helps. Secondly, I've been streaming now for probably 25 hours on this project for thanks for the follow, Dream Rossi. Thanks for the follow, man. I've been streaming and building this application which tests the round trip cold start time for AWS Lambda functions with tons of different configurations. We've done a bunch. We've done bun. We've done container versus zip for the same exact project. That's what we're doing now for Python. We've done that for Node. We've done different memory configurations. We've done loading or not loading the dependencies. All of this has gone into this talk that I'm giving at reInvent. It's massive now. It's already super long. We're going to be talking about memory, CPU, runtime comparisons in iteration, what makes your cold start cold, and how to improve it. So if you're at reInvent, if you're coming, let me know. Drop me a DM or just ! reInvent in the chat. I think my talk is full. It's COM 305. I think it's still full. But if there's enough people that continue to follow it and ask them, they may give me a bigger room. So, George, what's the time budget for my talk? My time budget is 1 hour. I'm really shooting for 45 minutes though. Judging by the response I've gotten so far on social media and talking to friends, lots of people have questions and want to kind of get in deep here. So we'll try and save a lot of time for that. A lot of time for Q&A. So yeah, we got to plug the system into this test plane to invoke it and run it, and then we can get these metrics like we've already gotten for other systems. I just turned it down for some of these, so there's not many new points here, but that's okay. All right. Create the application. I still can't believe Finch replaced Docker just with 3 lines diff in my serverless framework. Definitely watching on YouTube. Good. I hope you enjoy it. And I'm also probably going to give it live on Twitch. So I'll probably give a special version of it probably a week after. So for folks can ask questions, go back and forth. I think that would be pretty neat. And it will be on YouTube. It'll be on YouTube within 48 hours after I give the talk. So by December 1st or 2nd, it should be up. And I'll be, if you're not coming to reInvent, totally understand. I'll share it, and you can find it on social media. Big in the chill hop today. Okay, we did this. Sorry, I was texting my dog walking friend about getting the dogs together here in Boston. Sweet. Okay. 2 things, right? 3 things. Python 11, copy requirements.txt, run Python 3-m pip install-r requirements. Vegas is a 10-hour flight. I used to live in Minneapolis for a while, and I was there for 10 years, and every time I went to reInvent, it was awesome because it was a 3-hour flight. And now it is a 7-hour flight from the East Coast. Okay, that looks good. Oh, we shouldn't. Oof, yeah, big oof. San Francisco is like an international flight. Went to Portugal this summer. Love that. Went to Spain. Love that. That was a 6.5 hour flight. And then I fly to San Francisco, and I've done that like twice this year. And that's like a 7.5 hour flight. It's ridiculous. Going there, coming home, you know, when you go west to east, you get the jet stream. And let's give us a URL. True. I totally understand if you're a CDK user. I know I'm using the serverless framework here. I know that they recently announced Framework v4. I'll share my thoughts on that at some point. Right now, I totally think that they deserve to be paid for their work. I used to work there too, so I definitely understand and feel that. However, I really just don't like the press release. It was vague. It didn't clarify any of their pricing terms. It didn't clarify any of the divisions of pricing. It didn't clarify how pricing would work. It didn't clarify how extension authors or plugin authors, myself included, would get any money for their work. All of those, I think, are objectively like good things to do, but it was just totally... It was like, we're going to do these things and not here's what we've done. Here's why we think this is important. Here's how we think this will work. Like, I know you need to get out ahead of it and share this type of update with people who are using the tool as soon as you can. Totally understand. I really wish it would have been a much better written press release. Are we good here? Oh no, we're not good here because we need to //250 MB Python handler. We need to copy the imports. Right, pandas. That's the big one. Oopsies. I know. Oof. All right, we're still very much in taco sleep time here, so we're chilling. All right, let's do this. Cosmic Camel, thanks for the raid. How's the stream? Appreciate it. Welcome, everybody. Thanks for stopping by. Cosmic, hope the stream was cool, man. Hey, thanks for the follow, too. Everyone, shout out. How do I do this? I've done this before. Hold on. I promise I can do this. Thanks for the raid. Thanks for the shout out. Everyone, follow Cosmic. Appreciate that. Today, what we've done is we've been building these serverless applications, these tiny little Lambda functions. There's nothing in them. We're testing zip versus Python container for Python. We're testing the cold start time for zips versus container images for Python. We did it already with Node.js. And at the same time, Finch is a cool project from AWS that just went 1.0. It's a CLI tool for macOS. It's free. And we're replacing Docker with Finch, which is great because Docker Desktop on Mac has been giving me a lot of problems on stream lately. So learning Golang and Cockroach DB on my end. Yo, nice. Very, very, very cool. I have not done anything with the Golang or with Cockroach DB, but I write a lot of Golang at work. Big fan of that. All right, go back to this. And so what we did, Melky's Go Blueprint. Oh yeah, definitely check out Go Blueprint from Melky. It's a good project. Okay. Didn't get to your PR. Oh, I'm sorry. George, link to your PR. Why don't you drop it in chat? I'll check it out. So right now, for those of you who are new, didn't watch me do this, but I'm not running Docker, even though it's going to say like building image and stuff. We're running Finch entirely, and it's working really hard in the background. Yeah, please feel free to lurk. I don't have an exclamation mark lurk command, but I really appreciate you hanging out and I appreciate the raid. So we did some surgery on my CLI, the serverless framework CLI tool. So we replaced all of the calls to Docker with Finch commands. And that would actually be a really easy PR to open up, right? We could... I'm on my phone right now. It's just a workflow of creating a release on Git tag. Oh. There we go. All right, that's still building. So we did surgery on AWS provider. Let's just search for Docker. Boom, boom, boom. Okay. It's here. So literally all I did was I did a find and replace for every time it called spawn ext. I just replaced that Docker with Finch. And you can do the same thing on your laptop or on your machine by aliasing Docker to Finch or just overwriting it in like a little tiny script. You could put it in front of user local lib in path. If you've never done this, if you've never shimmed something on your own before, you should do this. So the path command, the order of these, you can see bun is hijacking it. Anytime you type anything in your CLI, it's going to look in order of these things in the path to resolve those binary executables. So you can see I've got some Datadog things in here. I've got core utils libexec for homebrew. There's RBENV for managing multiple Rubies. I have the unique experience of owning a bunch of code across tons of different runtimes. So I've got a little of everything. There should be .NET in here too. But all the way at the end, look at Rust. Look at Rust behaving so nicely. Cargo, very, very last thing at the very end. How respectable is that? But you can add your own shim here with your own like utils. And sometimes I do that and I override things. And that would be another option to do this for Docker. But what we could do is raise a PR to support like a configurable building tool. And then you can just use Finch, which would be kind of neat. Okay, let's see if this worked. Oh, sorry. I know I need to stop splitting. Actually, one second. Let me... Oh, okay, never mind. That's all open source code too. One of the benefits of what I do is everything's open source. I just want to make sure I didn't dox anything, but it wasn't. It was just an open source project. Cool. Okay. I know splits don't show up well on stream, and I apologize for that. Stet URL. Again, we know the cold start's going to be really, really bad the first time a brand new function is invoked for the first time. That's normal. Subsequent cold starts are a lot faster, and we're going to test that. That's why we're going to put it in the harness. Okay, that worked great. So it's time to modify our function names. So we have a 200 and a 250 we just added today, and we did them all with Finch, which is awesome. So we're deploying the cold start benchmarker. This is the project that goes and invokes those other functions at a regular basis. Regular basis. Naxo, hey, welcome back. I'm doing well. Hope you're doing well. Thanks for coming back to the stream. Just deployed our last Python serverless function, and we're now redeploying the invoker service. That's this bit right here, which is going to invoke all these different Lambda functions, and then will give us some metrics for the cold start time for Docker container images. And we did it all using Finch, and it didn't crash once. It didn't make me log in again once. I'm so happy with Finch so far. I will definitely be using it all week this week. Yeah, so that's been cool. I literally did, if you haven't, so I did which server, let's just actually do this again. I found out where Homebrew installed the serverless framework, and I cracked it open. Yeah, George, it shouldn't have worked on the first time. That feels like some serious, bad developer luck. What do we do? CD. Opt homebrew lib node modules serverless. So we did this. So inside AWS provider, I replaced all of those calls right here to Docker that I was showing you here inside of GitHub. Replace them all with Finch commands. Right here. So we can just, and then now it's just working. It's right out of the box, no problem. So the Finch team did a great job. If you're on a Mac, !Finch, you can check out the Finch tool if you're having problems with Docker Desktop. I don't think, I think someone already found out it doesn't work on Linux. I apologize for that. I should have mentioned that in the topic. I don't know what they're targeting exactly, which I think is interesting because I know a lot of AWS teams use Linux laptops. Okay, Linux client support, Windows client support, form extensibility. All right, hopefully they're working on it. Oh, here we go. It's loaded. I don't know why this is so slow. I'm on fiber. Anyway, thanks again, Cosmic Camel, for the raid. I appreciate everyone who tagged along for that. If you're new and you like what you see, hit that follow button. Helps me out. Appreciate it. Docker CLI on Linux works fine. Yeah, totally. I mean, it's because it's got the same exact, like the CLI and the runtime implementation for Docker on Linux is what they use to actually run containers in production. So of course it's going to be way better. It's mostly an emulator inside of on Mac. Although I wonder how it works with BSD systems. I'm sure it's fine. I shouldn't spout nonsense. I don't know anything about the Docker project, really. I just know that I struggle with Docker Desktop on my laptop. But this is great. That worked awesome. I'm super stoked about that. I want to see, okay, so this deploy finished. Yeah, it did. Okay. I need to use pushd and popd more for directories. I've gotten out of that habit, and that's on me. Okay, so let's go back to our metrics. We see 27. If this worked, we should have a lot more. Oh, it's on a 10-minute interval now. That's okay. Let's let it sit. Should we do the Lambda Layers rant? Should probably do the Lambda Layers rant. Okay. Let me get set up real quick. Go into secrets mode. Yeah, BKR, feel free to DM me. Anyone can reach out on Twitter. Do I have !Twitter? No, it's in my. It should be my social links though. It's you can find me. Feel free to reach out. Happy to talk about serverless stuff for any questions people have. Okay. What do I need to close here? Oh no, okay, I think we're chilling. All right. I do want to see if this is gonna run. What? I want to make sure this is working before I sign off and do. Or I'm sorry, before I do the layer rant. What's it running at? 10 minutes? Let's just give it a quick. Let's juice it real quick. Oopsies. There we go. Yeah, let's just do a 1 minute. Yeah. I can't believe Finch just dropped into my workflow like that. That's so cool. Sweet. Okay. Now we should get some data real quick, which will make me happy because I want to make sure we're collecting the right stuff. Next, I need a rant on DynamoDB strategy for many relationships. I mean, you're just in charge of your own referential integrity, which is scary and should seem scary. Cascading deletes are the scariest part, or cascading updates are the scariest part. Maintaining the relationship, I think, is okay if you don't need it consistently. I mean, you could even you can maintain that stuff in like a DynamoDB stream, right? You can do it entirely async if it isn't if consistency isn't super important, like you don't have to do it in a transaction. But then you're consciously making a decision, right? Like, will I query this immediately after updating it? If so, then it should be in a transaction. If not, I can do it async. And if it's going to be async, it should just be all the way async. Because there's never a guarantee. Like if you do it in 2 calls, there's never a guarantee that the second call is going to run before another query comes in. Okay. That looked good. Now, are we getting new metrics? We should have some new ones. There we go. We got a couple new ones. Okay, let's search for Python container. Python container dev. Okay, great. That's working. 0. I don't know where 100 is, but okay. Don't worry about these numbers for now. They will change. This is meaningless, but we'll let that run. That's awesome. Okay. All right. It is time to pause the music. I think my plan for this now is to go through the talk, or go through the blog post. I'll probably do it in video mode for just me fully. And then I want to go back through and talk about the individual parts where I think we should change. Does that make sense? Or should we, because I want to make this into probably like a YouTube video or a series of clips for this rant, because I'm sick of repeating myself every time this comes up. Let's see. Okay. DynamoDB many-to-many relationships Nexus says hurt me because I need to perform searches and filters that access patterns make the double access difficult. Yeah, that I totally get, and I'm sorry about. That is painful. All right, one sec. Okay. Let's do this. Speech time. Speech time. You probably shouldn't be using Lambda layers. Lambda layers are a special packaging mechanism that AWS Lambda provides to manage dependencies for zip-based Lambda functions. Lambda layers themselves are nothing more than a sparkling zip file, but they do have a few interesting properties which can prove useful in a couple of cases. However, I really think that the edges, the sharp edges that you can cut yourself on when you're using Lambda layers, they make them really difficult to work with and probably not worth using. They have a lot of challenges when it comes to deploying, developing your applications, and also there's a couple of tricky bugs that live within Lambda layers that you really have a hard time working through, there are a couple of tricky bugs that you'll have a really hard time avoiding if you use Lambda layers. So I want to start out and bust a couple of Lambda layer myths right off the bat. The first most common myth I hear about Lambda layers is that developers are using Lambda layers to circumvent or raise the 250 megabyte limit for zip-based Lambda functions. That's just not true. Lambda functions and all of their layers have to be under 250 megabytes uncompressed for zip-based Lambda functions. So it doesn't matter if those dependencies are in your layer or if those dependencies are in your function, as long as they all add up to less than 250 megabytes unzipped, you're okay. The second part that I think comes out of this is people think that AWS documents that Lambda layers can reduce the size of your deployment for a Lambda function. And that is technically true, but it's almost myopically true. And that raises a problem because, yes, in theory or in practice, using a Lambda layer can make a deployment faster. If we consider 2 Lambda functions, Lambda function A that is using a Lambda layer for all of its dependencies, and Lambda function B, which doesn't have any Lambda layers, it just bundles them up in the zip. If you don't touch your dependencies, yes, updating the function code or the function logic is going to be faster if you're using Lambda layers and not touching that part, right? You're just touching the little bit of function code. That's true. However, I mostly find that the time caused or incurred in deployment, or specifically the deployment process using any heavy dependency where you might consider a Lambda layer, is mostly spent compiling that dependency, right? If it's like a heavy binary, which I still think, and we'll get to this, it still may be worth using a Lambda layer for in that case. But regardless, it doesn't really change your deployment speed that much. The one exception to that so far has been if you have 100,000 Lambda functions and you have to update all of them. In that case, yeah, like if you have really, really slowly changing dependencies, it may be worth looking at a Lambda layer, but it doesn't change the 250 megabyte size limit. And the second thing that I always hear is that they're using Lambda layers to improve or reduce their cold start initialization duration. That's also not true. When your Lambda function has a cold start, it has to copy all of the code. It's already unzipped at this point, but it has to copy the source code from S3. Lambda layer is just like another source in S3 for that, and those files all get copied to the same place. So it doesn't improve any aspect of your cold start time. It doesn't change it at all. We've already tested this. We can test it again. But what really matters is the bytes you load. That's what impacts your cold start time. So let's talk about what Lambda layers can do for you. As I said earlier, in a specific case, Lambda layers can improve the deployment speed of a function when you don't also update anything in the layer. That's totally true. However, I think your CI/CD pipeline can probably cache a lot of these dependencies and keep these around for you. And that in and of itself is going to be important because your CI/CD pipeline is aware of the runtime of your language. And we'll get to this in a minute. Lambda layers have no idea what the runtime of your language is. They don't care at all, or the runtime of your code. It just is a bunch of bytes it applies on top of your Lambda function. Another thing Lambda layers can do for you is help you share code across functions. If you have hundreds or thousands of functions, maybe you stand up a new Lambda function for every one of your customers, or you have a couple per customer. It's totally true. Lambda layers can help you share that code across your functions. But I really wouldn't suggest using that unless you have to share those layers publicly, like if you have to publish them. And that's kind of what layers came out for. They were part of, I think, like the building block for what became extensions. And I think I consider a Lambda extension an exception to this rule. However, like Lambda layers themselves, there's not really a difference if you're going to share the code between importing it and using like the layer itself in terms of the actual runtime, right? Because all those bytes are going to be copied into the same place. Not really a big advantage there. There's two other major points in the documentation I want to address. There's two they say. So two things that they do say is separating your function logic from dependencies. I don't really think that's a big win here because it's the same, like my function logic is already separate from my dependencies. That's why I import them. It helps separate the deployment, which is nice in theory. And I'll get to this in a bit. There's also a really sharp edge there. However, it doesn't necessarily change anything from just importing another bit of code like you would in your editor. Finally, the last thing they say is this helps you use the Lambda console code editor. I like Cloud9. Cloud9 is an objectively good product. The little tiny Lambda editor that lives in the Lambda console for Cloud9 is not something I think anyone should be using to update their Lambda function code for any production use case. If you're brand new to Lambda and you want to toy around with something, that's totally fine. Use it. That's great. But if you're doing any kind of collaboration with anybody else, if you're uploading, you're pushing code to GitHub or pushing code to GitLab, you have any kind of source control, like you don't want to be directly editing production code. We know this, so that's not really a new thing. So let's talk about the painful parts that come with using Lambda layers. One of the biggest challenges for developers who are using Lambda layers is that layers just appear magically when the handler executes. They're just copied there and magically available upon invocation. That's cool technically, but it's a big issue because I'm editing code on my laptop in NeoVim or in VS Code or whatever, and my machine has no idea what a Lambda layer is. It has no idea where that's coming from. And the second I start to import code that doesn't exist, it's going to tell me about it. It's going to complain about it. That's what it does. That's what it's for. Your bundler doesn't really know about this. Of course, you can mark things external. Your test runners really don't know anything about this. Your lint tools don't really know anything about Lambda layers. And if you're building Lambda functions using like an emulator, I think only SAM actually uses Lambda layers locally. We'll actually pull them in. Other tools don't do that. So solving these issues is totally possible, but there's other problems here too. I think I've demonstrated this on stream before. I'm building a lot of my Lambda functions today on a ARM laptop on an M1. Maybe you're using one of the shiny new M3 MacBooks, and maybe you are deploying a Lambda function to Graviton. But we've already seen in Datadog State of Serverless report, like most people are using x86 processors. Of course, there's plenty of ARM chips, and those are only going to grow with Graviton. But today and for so long, it's only supported x86. So that's what people have used for so long. Lambda layers purport to solve this by offering a metadata attribute called supported runtimes or supported architectures. That's just a field. That field is just text only. It does not prevent you whatsoever from uploading or compiling or building some sort of dependency or a binary blob for ARM or x86 and slapping it on a Lambda function that is running on the other architecture. And it will just break with an exact format error. It doesn't care. These are just labels. The same is true for if I have like a Lambda layer that I build for Node 18, and then someone goes and imports it in Node 14 and it falls apart. Same with Python 3.11 or 3.8. Those are just labels. They don't actually prevent anything. They don't actually run. They're literally text labels. They do nothing. So that the cross architecture thing is an issue because I think more and more we're writing software for across architectures, or where you're either targeting x86 from an ARM laptop, or you're on an x86 laptop and you're targeting ARM and Graviton. In Lambda, those are all things that are just becoming more and more common. And because there's really no good method of enforcing either supported runtimes or architectures on Lambda layers, it's kind of just a risk, right? It's like another foot gun they're handing you. Okay, deployment difficulties. Lambda layers do not support semantic versioning. They're immutable and they're versioned incrementally. The incremental versioning and immutability is helpful because it kind of prevents unintentional upgrading, but incremental versioning don't offer any clues as to compatibility or changes in the updated Lambda packaging layer. So Lambda layers, because they're completely runtime agnostic and don't have any semantic versioning, you have absolutely no idea what's in them. You literally have to copy them onto your Lambda function, like attach them and run it and see if it will work to see what's in there. You have absolutely no idea unless you publish it yourself. In that case, sure, that's fine. Like I said, your package manager, NPM, PyPy, whatever you're using, is probably better at this because guess what? It's aware of semantic versioning. It has a package.json file or a pyproject.toml file or a gemspec file. It knows what's in your project and it knows what's in some other dependency or project you might pull in, and it will warn you if you have incompatible dependencies. Lambda layers don't do that, which I think is shocking because one of the main selling points of Lambda layers is that they share common dependencies between many functions. And that's great if every single function requires exactly the same dependency or the same major, right? A compatible version of that dependency. But what happens when you want to upgrade a major version? This is where things get really tricky. Now, let's imagine for this case, you have a steady state Lambda function. It is running, maybe it's doing, 100 concurrent requests, or let's just even say 10. How am I going to deploy a new breaking change in a Lambda layer? I would have to release the new version of the layer with the new major version. And because there's no semantic versioning, it's just n+1, right? So if I was on, my layer version 5, it's now my layer version 6, but my code isn't compatible with that yet. So no developer can upgrade yet. I have to go and update all of my code in my Lambda function. And then I have to attach that new layer. But guess what? I've already documented this. Deploying a function and a layer at the same time is impossible because those are two separate asynchronous API calls. Update function, which updates the function code, and update function configuration, which updates things like RAM, CPU, architecture, and also configured layers. These are separate control plane operations. They don't happen concurrently and they don't happen in the same change, which means if my 10 requests per second are invoking the latest, Lambda function, the latest tag, that will fail at some point when one of the two changes is applied. Either the layer with the breaking change is in place before the update function code is finished, or vice versa, right? The update function code is finished, but I don't have the latest layer, so it's got a breaking change for some API that I need that's in that layer, but it's using my layer version 5 instead of version 6 until that update function configuration call finishes. The only way to handle this is to use versioned Lambda functions. So you publish version 1 or version 2 of your Lambda function, and then you publish another version with that updated Lambda layer. And then once both of those operations are completed, you can point the alias from whatever your integration is over to that version of your Lambda function. A lot of people don't do this. It's true that semantic versioning isn't perfect. There's flexible specification for dependencies like the tilde or the caret, which will say, I want anything under this or over this up to, 2.x or something, which does mean that the combination of bits executing on your Lambda function may run together for the very first time in staging or production or on Lambda. That's caused a lot of issues. That's why we have things like npm shrink wrap, but it's even worse for Lambda layers. And that's kind of my point. This is what your package manager should be doing. Now I want to talk about one really nasty bug that can happen with Lambda layers. I call this dependency collisions. Lambda layers can cause a particularly nasty bug, and it stems from how Lambda creates a file system from your deployment artifacts. If you followed me on social media or you've heard me write about this before, zip archives themselves have a similar bug that Lambda is not immune to, where you can put two files with the same name in a zip archive. That's totally valid. But when you unzip them, that's not valid on any file system, on like ext4 or whatever the destination file system is. So you either have to choose which file you keep, or it will just pick one for you. Lambda does something similar. If you have, you can have up to 5 layers on a Lambda function. If you have 2 different files with the same name in either of those layers, they're merged in order. So layer 1, and then layer 2, layer 3, layer 4, layer 5. Layer 5 will override everything else all the way down. However, your Lambda zip code is actually copied into a different directory, but when your runtime starts, it is going to use that path environment variable, or if it's Node, it'll use node path or gem path for Ruby. I think Java has class path. And it will import code. It will look for a dependency in order in the directories, either in path or in those specific paths. So if you supply a dependency in a function zip for, let's say you dependency A at 1.0 in your zip file, that's great. It's there, no problem. But layers are referenced earlier in the path. So now you apply layer 1, maybe that has A at 2.0, or maybe you have layer 2, which has A at 3.0. Guess what it will be imported by your function handler? It's going to see that last Lambda layer. It will grab dependency A at version 3.0. And if your function zip is written for A at 1.0, you're going to have a breaking change conflict. You're going to have a breaking incompatibility change. It's going to crash your Lambda function. And this has happened to me. I've had this issue before. I've actually ran into this issue with people who were using a different version of, I think it was Next.js that had a different version of a dependency that we also had, and their version squashed ours, and the customer's handler broke. And there's nothing I can do about that, because guess what? Lambda layers don't provide semantic versioning and don't provide package metadata or any information about what's in that layer. So there's no way to guarantee compatibility. That's why everybody who publishes a Lambda layer also has to publish a PyPy project package, or a tarball, a npm package, or something else somewhere in a native packaging environment, so users who have this issue can work around it. So where should you be using Lambda layers? I think there's really 3 main points where you would consider this. The first is if you have a very heavy shared compiled binary, something like ffmpeg or sharp, or an image resizing library. It's one of those dependencies that you don't change often, that has a solid API that has been well established, has been used for a long time. It's not going to change, even if you have to update a minor version here or there, no problem. And you don't probably have to deploy it or recompile it hardly ever. I think that probably makes sense to be in a layer. The next would be a custom runtime. So Bref is an immensely popular PHP runtime. It's packaged already up for you in a Lambda layer, precompiled for both ARM and x86. And I think that kind of makes sense as a layer. That is a binary, it kind of falls in that binary extension exclusion from my rule. Bun does the same thing, where they have their own layer that they publish for you that you can use. Although, as we've shown, on this stream, it's far more performant to use a container image instead of their layer. And there's subject for another post. Finally, and most importantly, Lambda extensions. Lambda extensions have access to extra lifecycle events. They can do asynchronous work. They can do background work. They can run code after your Lambda function exits. These are all things that your Lambda handler cannot do outside of an extension. All extensions are delivered in a Lambda layer for zip-based Lambda functions. And if you're considering, or if you have to do any of these things, maybe you have to flush telemetry back to a provider or something like that, Lambda layers are the only way to do this, and it's a worthwhile exception to these risks. They're also typically precompiled, and they're statically linked compiled binaries. so they won't suffer for these type of dependency collisions that I talked about earlier. So to wrap it up, there are a few specific cases where it's useful to use a Lambda layer, Lambda extensions, have you compile binaries or maybe a custom runtime. But I really don't think you should be using Lambda layers to replace runtime specific packaging and ecosystem tools that you already have, like NPM or PyPy. Lambda layers, they don't offer semantic versioning. They make it really hard to deploy breaking changes to your function code and your layer. They cause a bunch of headaches during development. And no matter what you do, you are still susceptible to these dependency collisions I've spoken about. So use your package manager wherever you can. It's a more capable tool. That's what it's there for. Use that tool. Don't use Lambda layers. All right, that's my rant. Well, hopefully I can cut that up. Happy to answer any questions if folks have any. I know there a couple of chat messages went by and I missed Or Plaza. Thanks for the follow. This post should probably go out later this week. But I know that most people prefer this type of content in a video form, so I'll try and share it that way. Hopefully that worked. Hopefully folks enjoyed that. It is, there's just like a bunch of edge cases here inside of Lambda layers that I just really don't think are that useful for the problems they purport to solve. So I wouldn't suggest that. Thanks, Naxo. I appreciate it. Gonna sit back down. The dog decided it was time to leave after I started ranting. Taco got up. He's like, I've heard this one before. Joyce, the arch label seems really odd to me. Yo, it's totally true. It's completely true. There's nothing stopping you from doing this. And here, look, like watch how easy this is to do. So let's go to a Lambda function. Let's go to an x86 Lambda function that's working just fine. Here we go. This is fine. Let's test it. Test. Started. Success. 200. Okay. Like everything's fine, right? This worked just fine. Now, let's go and grab a layer file. 1 second. Let me grab we're in US East 1. Okay. So let me grab the ARM extension. This is a Datadog's extension. It's public. Anyone can just pull it. This is one of the, I work on this, so fine. Configuration. Oh, oops, sorry. You go to code, you go to edit, layers, add layer. Remember, it's x86. Let's see if this still fails. Verify. Totally fine. Compatible architecture, ARM64, no problem. No error. It's like, yeah, sure, no problem. I'll add this for you. No warning. Successfully updated this service. What do you think is going to happen? What do you think is going to happen? No problem. We've got an x86 processor and we're running an ARM binary. No problem. Oh no, it failed. Oh, exec format error, launch error. Wow, this would have been nice to see. It would have been nice to see when I applied a damn ARM layer to my Lambda function. But no, it's just a label. It's just a label. Just text, man. This is the best example of job done, boss, I've ever seen. It's like, hey, did you make those compatible architecture flag changes? Yeah, boss. Job done. We got that field. It's here. It's just unfortunate. It should be good. It should be better. No warning whatsoever. No warning. George, I feel like I just blew your mind there. Like people don't believe me when I tell that to them. Fix that Lambda function, boss. No problem. Yeah, it does seem like something. What link is this? This is fine. Yes. That was risky. I should have previewed that. Yeah, this is this is fine. It does seem like something they could, and like I totally understand the complexities, or maybe at execution time for the Lambda team to make that work. But why can I not just like, why on earth is this a thing? You know, why on earth can I not like just warn people? Oopsies. Like you already have this, right? Like if this doesn't exist, oh, it doesn't exist. Amazing. You've done the check, right? You know, like I can't save this, it doesn't work. But an ARM version, compatible runtime, it's right here. It's literally right here. Totally fine. So I think I would suggest Lambda layers if they did two things. If they started actually, hold on. I'm gonna stop the music because I'll probably clip this into the video. I would probably use Lambda layers if they fixed the unchecking of compatible runtimes and compatible architectures. Like if these two things were more than just a text field and actually did anything, then I could probably get behind using them. And then the second part would be if they had some sort of compatibility system, if they had some type of semantic versioning and compatibility mode where I could give them a manifest file and say, here, you know, like, and manifest could be arbitrary and multi-platform. It could be like a package lock file. It could be a, you know, pyproject.toml or poetry.lock file, or any of those types of things that you use in any of the languages you write, you know, Go mod file, where at least then I can check what is in that layer against my own project and see if it will work. I guess Go's different because it's statically compiled, but you get what I'm saying. If I could actually see what's in there and see if there's any incompatibility, that would be huge. The fact that I can go into a x86 Lambda function here, that's totally fine, right? This project is, this code is fine. Everything's successful, executes fine. And then I can add a Lambda layer with a different architecture that will never work. And it will happily just save. No warning, no exception, no, hey, you shouldn't be doing this. Just this little thing right here. I can see this. This is already a mismatch, right? And the same if I had a compatible runtime. The fact that I can do this and everything works, and then when I go to actually run the function, or if, you know, it's backing an API and God forbid a user's using it, first thing that happens is it fails with the format error. Because of course it is. It's compiled for ARM. I just don't think that this cuts it for a production software system. I just don't think this cuts the mustard. You know, you got to do better. This isn't the bar. It's not the bar. Oh, I wasn't even recording that. I can get it from the VOD though. Being a content creator is hard work. I'm just doing it for fun. All right. Let's go back and look at those metrics quick here. Do we have any new data? Here we go. That's looking good. Let's give it the last hour maybe. Okay, that's looking a little bit better. Is the soy jack thumbnail ready for the video? I don't know what that means, but I don't have any idea of what I should do for a thumbnail either. I don't know what I would do here. A giant head with don't use layers. No, I need to do that. I think what I would do, so in the talk, I've used this example. Oopsies, that's the wrong one. I've used this example here, and I think that's what I'll try to do, is something similar like this. Maybe I'll do the giant head part. I'll probably have to give the talk the talk one more time end to end. I wanted to bounce it off a few folks here, and it looks like I surprised a few of you with these facts. But I'll probably use something like this for for the actual video thumbnail. Yeah, but there you go. Lesson learned, right? Don't do that to yourselves. All right, we've got some data rolling in. I don't know where my 100 megabyte Lambda function went. We should probably fix that quick. Is it not in the... Is it just not being called? No, it's just not being called. It's literally deployed. Okay, let's make sure it's deployed first until we... Make sure this works. Oh, it's got the platform arg there. Oh, duh. Okay, this is after I was using Finch today, so it's totally fine. It just isn't plugged into the cold start benchmarker. Yeah, we shouldn't have to. I just wanted to get... Ugh. Come on, go into scroll back mode. Thank you, Tmux. Oh, no, we need this one. Literally just missing it. Okay. It's going to be a sad space to explain why the data is missing for that one. So yeah, thoughts on Finch. It's good. If you're running Mac OS and you're having challenge with the Docker desktop like I was, try it out. It seems great. I'm not a big fan of the GUI. If you are, that might be more of a challenge. I should probably couch that a little bit, right? And say that you don't get a GUI with Finch. Do you get logs? You gotta get logs. There's no way you don't get Finch logs from a container. Oh, and it's got support for Compose too. Okay, that answers a lot of my other questions. Sweet. All right. We should get another metric in just a second. Let's go and check CloudWatch logs and see. GUIs are so 2015. I'd probably like them a lot better if I was good at making them, and I'm not, so then I'm, jaded and uncomfortable. There we go. Okay, I created it. Good. There we go. 100 megabyte. Okay. And I have to put these in order, otherwise I'm going to go blind with rage. Hey, Regalius. Welcome back. Good to see you again. Have you tried AWS Batch, the service? No, I've not tried AWS Batch. I've got thoughts about batch processing SQS messages with Lambda. And remember, folks, kind of ignore these first couple points. As you can see, as the cache becomes more hydrated over the course of a couple of invocations, it gets a lot better. Pretty solid stuff, though. And remember, this is round trip latency. I probably didn't explain this. I know there's a few new viewers here. We're doing round trip request latency, and we're doing that because of this. If you just look at the init duration, you're not seeing the whole story. Init duration is only telling you how long that Lambda function took to initialize statically. It doesn't tell you how long it took those bytes to get into the VM. So you can very easily see this if you look at the duration from 0 megabyte Lambda function where it's not loading any code and it has no dependencies. Initialization duration is 172 milliseconds in this case. End-to-end duration was 266. I'm sorry, not end-to-end, but time spent in Lambda. But if you see a 250 megabyte function where we're still not loading the code, right? So I don't have any import or require statements. It still reports an initialization duration. Oh, so sorry. Move it to the left. Thanks for the reminder, Cosmic. Let's do this real quick again. I got to pull up my stream preview a little bit better here. I'm on an ultra wide monitor. Ultra wide, by the way. Here, that looks a little bit better. Okay. So we can see that the system reports 266 milliseconds in end-to-end duration inside of Lambda for 0 megabytes. And if I take the exact same handler code, but I just add a couple of other things into the zip file, a couple of other node modules that I don't load, we can see that it still reports 172 milliseconds to initialize, but the user waited 845 milliseconds for that Lambda function to run because it had to copy all of those bytes from code store. And for a zip-based Lambda function, that's S3. It has to copy all of those bytes over to the Lambda function before it can execute, even though it never loads any. So that's why we built the system that I've been talking about here on stream. And we already pulled all this data a while ago. If you don't load any bytes and you don't have any in the zip archive, it's like 350 milliseconds round trip for like a request. But when it runs, it's faster. Yeah. Welcome to the chat. But yeah, it does run faster. And you can see that here, like 250 megabytes runs in 695 milliseconds if you don't load any bytes. But if you load all of them, it runs in 5.47 seconds. These are the same node modules in each of these. Oh, 99. Hey, welcome to the chat, 99. So we did this comparison on stream probably a month ago, but it creates this chart. And this chart is the opportunity zone for Lambda. And I call it that because, yes, it's true that 0 megabytes will run in 300 milliseconds and 250 takes, 700 to 800 milliseconds to run. That's nothing compared to what it would take if you load every single byte in that package. So if you have a mono Lambda function, if you have a single function that serves many routes, and you don't need all of your dependencies for any given request, don't load them. Load them later. Typically, you wouldn't do this outside of Lambda. For Node.js, when you import or require a file, it will pause the event loop. So if you're processing hundreds of concurrent requests in like a server, probably not a good idea. However, in Lambda, it's a great idea because you're only serving one request at a time. So totally doable here to take advantage of this opportunity zone and only load the bytes you need. And the way I kind of think about it is like you give users different, like a little bit of latency depending on the requests that they're loading. And then by the time that specific Lambda sandbox has loaded enough of the code or like all of the code to serve maybe a dozen requests, then it's warm for the rest of the time and it's fast, no problem, right? No additional latency at all. So this is sort of the zone we're looking at, and that's why we're comparing loaded and unloaded Lambda functions. Unrelated serverless question. How do you host WebSockets without breaking the bank? It depends how chatty your WebSockets are, is the real answer. If they're super, super chatty, I would probably not run them on Lambda because you pay not only like execution time every time they fire, which that's actually pretty cheap, but I believe API Gateway counts them as a request for every WebSocket like push or pull. So it's just not cheap in API Gateway terms. Yeah, it's like per event. So I wouldn't. I'm very happy. I've been on the stream a while talking about like App Runner and Fargate. I'm really happy using both of those services. Once you're over that like $20 per month. No, so regardless, that's what I'm getting into. Like once you're over the $20 a month bill, you're in load balancer territory, and you can use ALB instead to host that API. I believe it will forward WebSockets to Lambda. Does it? Let's find out. Oh no, WebSockets are not supported. What? But a regular like Fargate would be. So that's probably where I jump into Fargate. That's good to know. I totally assumed they were. Honestly, you might also look at just function URL and REST requests. Like, I don't know exactly what you're doing with WebSockets, but WebSockets assume some amount of backend server state that you don't really have with Lambda. So if you're trying to like keep track of counters, you have to do that outside of Lambda anyway, right? You have to do that in Dynamo. You have to do that in a cache. You can do that in Redis or something. 99. So my program is a monolith, no dependency, and even contains all the data it serves. No login, yada yada. Just plain simple free API. Is it cheap on AWS? Yeah, it's super cheap on AWS. I would probably run that in Lambda. And there's a couple of easy patterns to do this. I would use the Lambda web adapter. This is a great project. 10 out of 10 would recommend. It is a Lambda extension. So it is a layer. I know. Don't at me. But you can, it's an extension, which falls under the exclusion categories we talked about in my rant. And it allows you to just drop any Docker or any container image you have in Lambda, no problem. Like just straight off the bat, if you're running Flask, if you're running, Rails, if you're running Sinatra or anything like that, you can throw it in there. Layers don't improve cold start speed. 99. It doesn't change anything. Layers won't improve your cold starts. The bytes you load are what matter. I just do it on server since Lambda isn't really working for me. Yeah, Kochi, I'd be curious to see exactly where it's falling apart for you, but I totally it's a success point if you go from Lambda to something like ECS or Fargate or App Runner or Cloud Run, because you're getting a bunch of traffic, and that's probably a good thing. And then it's cheaper, and that's great. I still run a lot of stuff in Lambda because I like the benefits it provides, but I still I'm of the belief that Fargate and ECS and App Runner are serverless services. A little less so because I really want a service to scale to 0. Cloud Run does that. It's amazing. Cloud Run, great service. Love that. Fargate's also great. You just pay that $20 a month for each load balancer. Depending on how your services are set up in AWS, if you have, small services that are all talking to each other and they all require a separate load balancer, that can be a little expensive. And then you'd probably be in App Runner territory, because App Runner includes a free load balancer, but then you pay for just the time it's running. It just doesn't scale to 0, which would be great if it did. Thinking about making serverless WebSockets myself, it seems like a lot. That's kind of a loaded term. It depends what you're doing with WebSockets. There are a lot of tricks you can do, though, within Lambda to make this type of thing work. Like you can still store state in your Lambda function. You just can't guarantee that each user hits the same function. I played with a little project that replicated sort of what HashiCorp's console does with Lambda. So it's I think Paxos is what we were trying out. But it will communicate with other Lambda functions just by invoking itself. It's either Raft or Paxos that we were trying out. I don't remember exactly what we were coordinating with, but I was working on the actual extension that did it. And it's because Lambda extensions can run when the function is shutting down. So when a Lambda function is about to die, you can hand off state to another instance of a function and just keep, passing it around. And that sort of works if everything fits into one Lambda function in memory, but it doesn't. If it's more than, at the time, 6 megabytes was the limit that you could send, then it doesn't really make sense. But there's no networking advantage. You have to do everything over REST. It goes on, it's still in their internal network because it's like Lambda calling Lambda. So it's all internal fiber and very fast. However, it's still a full network stack. It's not going through any sort of, it's like going outside of the firewall, executing and then going back in, which would be faster if you had a VPC with, servers running in a normal cluster. It's funny to me that they're even telling you right off the bat, it's a Lambda layer, you can use it, but they're giving it the instructions for running the web adapter first as a extension in a Docker container because they know that's what you're going to bring. And that's kind of the point. Your application is probably already in a container. So just copy it over into Lambda, drop this extension in, it'll proxy events as HTTP to your container, and it'll work. Oh, you may have to implement a readiness probe, but you probably already have that. I'm sad that ALBs won't handle a WebSocket for Lambda, but I guess that kind of makes sense. Oh, and your limited ALB limits you to 1 megabyte, which is a bummer because it's 6 otherwise, and it's actually 20 if you use like a function URL, and that's a soft limit. I realize that that's different. Like, I don't think most people are sending 20 megabytes of JSON, but I think it's kind of a neat thing. Dang. This is great. I can't believe we got Finch just to work like that. I'm so stoked. Oh, there's a whole live like top for Finch. That's awesome. Yeah, definitely check out Finch. I pleasantly surprised, had high expectations, told people that I did. That's working great. Love that. Okay, so we did the Lambda Layer rant, which I'm stoked on. We did the last of our Python container test, and we're gonna see what these metrics are. We gotta let this is like a little, you know, just a little project baking away in the oven here. Look at that round trip latency start to drop. That's awesome. Oh shoot. Okay, I totally missed this, and I've got only a little bit of time left, but I am not running the actual versions of Python. Why am I not? It's Python. Hashtag like it. Yeah. For better or for worse, I write a lot of code in a lot of different languages for my job. Do we not have... Oh. Okay, so we have to make a quick 50 megabyte project. I already have the requirements file, so it should take just 2 seconds. Coming from star ISP is still too much other languages, too much syntax and blah, blah, blah. I assume you mean Lisp. I would say I'm definitely in a situation now where it's like jack of all trades, master of none. Although I have a really fun project that I'm working on for my job in Rust right now that I'm really excited about. Having a lot of fun with Rust. I think there's a lot of nice things it does for you. It's a little CLI tool or like kind of scripting tool. Really liking where that's going. One day I'll be able to talk about it. I can't right now, but one day. Python container, 50 megabyte app dot. Okay. Oh, it's just NumPy. Okay. Nate Codes, hey, welcome to chat. First time chat. Check that out. Thanks for stopping by. Teaching kids Python means I can get a job if for school dropouts. I think you can, you can kind of, if you're a software developer and you like it and you get you get your head on right, you can probably get a job in a lot of different environments. It's just not. I think it's a hard hiring market in certain cases, but there's tons of manufacturing companies and technology companies that aren't necessarily software related that you can work at. My wife works in biotech here in Boston, and I've helped her a number of occasions write little scripts to convert like CSV files and file formats between, CSV or tab delimited and to format little bits of data for her research, because they'll have like machine A, which will read a file from S3 perfectly fine, but it won't talk to machine B directly, and it needs like the data in a little different format. So just more than happy to write a little script and do that. And I think there's like tons of companies that do that for, for their full-time job. So many companies using old language and text. Tons of COBOL and Fortran out there. Yeah, maybe. I mean, yeah, there is. That isn't what I'd suggest anyone learn. I think Python, JavaScript, Go, all these are great. And we don't hire for language competency. If you do an interview with us at Datadog, you can pick whatever language you want to do the interview in. We don't care. I've had people do it in C++, Java, Rust, Go, Python. I mean, I did mine in JavaScript, in Node. It's fine. It's not something we don't care. So, non-trendy tech stacks. Yeah, I mean, I was like a Ruby on Rails developer for like 8 years. I guess it was probably trendy for a little bit, but it's not anymore. And there's still plenty of Ruby on Rails jobs out there. What are we doing? Oh yeah, we had the handler. PHP still slaps. There's nothing wrong with PHP. I think this is all good, actually. People will still be deploying Ruby apps in a decade or two. Yeah, absolutely. Standard library in JavaScript is not good enough for a few DSA interviews. I end up using C++. Yeah, I mean, Go doesn't have a set, and you can get by with a hash map. So, I mean, maybe. I also, in some of those cases, I provide like a little, if I'm going to do like a tree question, or if I'm going to do like a graph search question, I'll provide some of those boilerplate classes. That's fine. I'd be too scared to do a DSA interview in C++. Yeah, Nate, that's quite the spread. PHP first, Symfony, and Laravel. I mean, Laravel, what? Like Laravel and Lambos, right? That's what everyone jokes about. Oh, Lambda layers. It's like, this is true with an asterisk. This is fluff. Update or separate core function from logic from dependencies. I have an import statement. I mean, that's fine. Share dependencies. Yeah, it does. But I can just do that with I can do an NPM local package. I can do a private package. I can do any of those things. Lambda console code editor. Don't do this. Don't use that editor. Okay. Active model. There's a name I've not heard for a long time. Uh-oh. What do we do? Oh, I have a requirements.txt file and I didn't include I didn't include anything. That's on me. Just copying Rails patterns and APIs to PHP with magic methods. Yeah, I mean, magic methods are a little annoying. I mean, they're very annoying, but once you know how they're defined and what they do, it's not that bad. Like you know where they're coming from. You load a class. That class can create some methods for you. You can call those methods. 100 MB Python. Oh, really calling Dockerize pip? Oh, okay. Let's see if Finch works with Dockerize pip for serverless Python requirements. Did it add it? Yeah, it did. All right, so now we're calling Finch. Ah, there we go. Okay, so the plugin serverless Python requirements is shelling out to Docker, and Docker isn't running because I killed it. So let's see if we can plumb Finch into serverless Python requirements. No. Dang it, NeoVim. There we go. All of this code is to like Docker command. Docker is too much. I think we might have done it. My old and good friend Daniel created this library, and he is very much, you know, you can very much see it, his code and his fingerprints on this, where it's one entry point, sort of one place where it writes the command, and then it appends when it needs to via different methods. Although I'm really more of a fan of the pure function approach here, especially because it could be. There's nothing wrong with that. Okay. Nate, once we had a full release, we were just like, cool, let's use Laravel now. Nice. No, don't. Where's it running that command? I might have to actually read the code here. What is it doing? Pip and v docker.js. Here we go. Oh, yeah, this is more what I expected. Command equals Finch. That's what I'm talking about. Oh, hey, buddy. Look who's back. Look who's back. Welcome back, Taco. I brought the bed in here for him, and he's just laying on the carpet. Is it time? All right, it's gonna be that time. I gotta do this. Let me finish this, buddy. I'm gonna finish this, and we can probably take him to the PARK. Taco chilling. Yeah, he's chilling hard. Just, I see now why Dax is a Zuko cam. It makes perfect sense. Yo, do y'all see this? Do y'all see what just happened? We just replaced serverless Python requirements entire Docker implementation with Finch, and it's just done. Just worked, no problem. Updating, deploying, building. Pretty pleased with that. Okay, that worked. That's awesome. Let's curl this, make sure this works. There we go. Go serverless. Okay, great. We got to plumb this function name in. And we got to start calling all the other Python functions. All right. So those are the containers. Now we need the non-container versions. 0, 50, 100. Uh, 150. Okay. 200 and 250. All right, so once this is done, we should have a pretty good answer about how AWS Lambda functions with container images perform compared to zip-based Lambda functions with the exact same code. So it's the exact same, I shouldn't say exact same code, right? Because the container image is gonna have different binaries than maybe the managed runtime, but it's the same dependencies and it's the same application code. I think that's pretty neat. That was a question that the Randall from Kalen had. If any of you have questions or something you want to see on stream, let me know, send me a DM. I didn't get to the SQS batch retry or batch failure example. I'll do that maybe tomorrow because it's really, really impactful and I can show you a really good burn down curve. And like, say, you know, we have like 1 million messages in a queue. How fast can we burn them down if maybe 1 in every 100 messages fail? And I'll show you the difference between doing that with like raising an error in your Lambda function or doing that with batch item failures, because it's just so much more performant. Every time your Lambda function throws an error when it's consumed by an SQS queue, the event poller, or they call them the poller or the event source mapping service that pushes messages to Lambda via polling on your queue, will reduce the concurrency of your Lambda function a little bit, and that can kill your performance. So awesome. Okay. I think that's solid. We got to wait for all these metrics to show up. Service, it's what? Python dev. Okay, these will come in a second then. Hey Flask, Flask, welcome to the stream. Thanks for dropping by and saying hello. Did I develop Finch? No, I had nothing to do with Finch at all. I complained about the tooling of macOS and Docker for a while, and then I got a DM from somebody who works on the project and said, hey, check out Finch. This was early. Finch was, at the time, still in development. It was like 0.x. Had a couple of problems with it, and they just went 1.0 3 days ago. So I agreed to check it out. I really like it. So far, I've replaced it in two of my CLI flows. I did that here on stream today, and it worked the very first time, which is crazy, but it worked totally fine. You know, basically dropped it in and replaced everything you would run, like Docker run, Docker build, Docker start, you know, Docker tag. No, Finch, it'll talk to any repository, any ECR. It doesn't care. It's all running locally. This is it's a tool for building and running containers on your machine, specifically on a Mac machine. It looks like on the roadmap, Windows and Linux are coming. Hopefully Linux first, but the idea is it's meant as a container development tool. So you can run container images. I typically build out of container images, right? So I'll cross compile. I'll use like Docker build or Docker buildx. If you are building any kind of library where you want to make sure that you have a consistent set of dependencies every time you publish or build that library, it's great to use, you know, something like a Docker container. Kochi, it's great. Just try building it. Yeah, it's great. It just works. 10 out of 10. Would recommend Finch. I'm sure I'm going to run into an issue. I'll open one on GitHub and we can talk about it or something. We can even probably hack on it. My understanding is it just it pulls a bunch of other tools together and makes it super easy, and it gives you the same API that you would use for Docker, like the same command line flags, right? The same command line tools and commands work with Docker and work then with Finch. So you just drop it in. The only thing so far is it doesn't have a GUI, which it's just not a problem for me at all. All right. And yeah, thanks again for the questions. And thanks again. If you are new here, hit that follow button, drop a follow. It really helps me out. I appreciate it. Let's see if we've got any more of these. Are these coming in yet? Python dev. Yeah, exactly. Like I think, sometimes it's nice. Hey, thanks for the follow, Flask. Sometimes it's really nice to have a GUI, but I just haven't had that issue with Docker specifically in a while. I wonder if I have a bug here because I'm not getting any metrics for that function. I wonder if it's blowing up. Uh-oh, invoke error type, resource not found. 250 megabyte not found. Oh, do we just have to deploy that quick? And I'm sure if it's a big issue, people will like support it, you know? It's open source. And okay, so I think tomorrow I'll try and stream again for a little bit and we'll try and talk about, let's get some clear space. We'll try and talk about SQS batch item failures. Oh, why is this center aligned? So we'll try and talk about that. That's a big one. This is a really, really important thing. And actually, it's not just SQS. It's any kind of event. If you're using Kinesis, you have to process a record or you have to like read past those bytes. So that's a little different. But SQS will happily fail and retry over and over and over again if you configure it too. So that's a good one. Open source work on Lambda stream. So looks like Finch is mostly Go. Yep, as is Docker. Yeah. I actually haven't read any of the Docker source code. What I have read a lot of is the Lambda Firecracker runtime source code. It's all in Rust. It's really simple, actually. But it doesn't, it's like lightweight. Or it shouldn't. It does a lot, but it does a lot by doing little, if that makes sense. So we should work on, oopsies. And yeah, if you're using AWS Lambda streaming response in your functions and you're using JavaScript, check out the open source library that I published for that. We'll probably try and work on some of that tomorrow. Did this deploy? I need to make sure this worked. Oh, why is it 200? That's not good. Oh my God, I bet you it is... I didn't rename the service when I made this one, so it's just 200. Oh, that is a big L. No, I overwrote my 200 megabyte service because I use the same name. See, I'm in the 250 megabyte Python directory, but I accidentally called it 2. Oh no, that is a big L. That sucks. Okay. It's the same stack though, so all I have to do is redeploy this code. They're pointing to the same stack, which is okay. So I don't have to remove this one. I just have to rename it. Oh, Flask must be nice. Never did this ever in your life. Must be nice. Okay, let's just go then. 250 MB Python and vim serverless.yaml. Oh, you just get got like that. You know what I mean? That burns. Is this working now? Let's look at the rest of those logs. So it should tell me which metric it emitted. Oh, it's failing. That's why. Okay. All right. Never made that mistake. Thanks, that cracked me up. He's looking really sad over there. You know he's sad when he's sleeping off of the bed. When he's moving off of the bed. All right, I'm gonna set us up with a raid here. We'll probably go and raid Mr. CM Griffin. I do really appreciate everyone hanging out today. Again, if you're new and you like this type of content or you have questions about serverless, drop them in chat, drop them in my DMs, and hit the follow button. Really appreciate all the time today. Let's set up the raid, and then here, ready? You guys want to see something? Hey, Taco, go for a rip? You wanna go for a rip, bud? Time to go for a rip? Let's go. Yeah. Want to go to the park? Just go see your friend? Go for a rip, bud. All right. All right, y'all. We're going to raid Griffin. Thanks again for hanging out. Really appreciate it. We'll see you again, hopefully tomorrow. I know. We're going. You don't have to whine.